So some more practice with scatter plots here. This whole unit is, as you've seen, pretty short, and it's all just very focused on one concept of scatter plots and lines of best fit. So again, we're just going to have another practice worksheet going through that. We are adding one small element of correlation in today, and we'll also see it in the next assignment, a little bit more on correlation. So we're going to classify the scatter plot as having a positive, negative, or no correlation. And that means, are the points trending downward? Are they negative? Are they trending upward as we go from left to right? That's positive. Or are they just kind of thrown all over the graph with really no correlation? There's no rhyme or reason to them. So for this first one, I would say that the points are kind of just all scattered all over the place. So I would say, there's neither. There's no correlation. It's not positive. It's not negative. For this second one, if I were to draw a line through these points, it looks like our line would be going down. So this graph has a negative correlation. If I drew a line of best fit, I just kind of arbitrarily drew one. It's going downwards, negative. This one, if we were to draw a line through the points, we would have a line going upwards or a positive correlation. Number 4, again, draw a line. These points were all very close to the line of best fit, so this is a positive correlation. Again, very tight points in a negative correlation. And then a circle, it's not going up, it's not going down, so neither. Hopefully that was pretty easy for you. The next one, a history teacher asked her students how many hours of sleep they had the night before. The data below shows the number of hours the students slept and the score on their exam. Plot the data on a scatter plot. Okay, so to save time, I already have those points there for you. And then let's see. So we want to draw the line of best fit in there. So I need to come up with my linear regression equation. So we'll pull up Desmos here. Exit out. Okay. So we'll go plus table, and then we'll type in all of our values. Hours slept, they told us are our X values, and test scores are our Y values. So we have 8, 7, 7, 8, 6, 5, 7, 4, 9, 7. And these don't need to be in any particular order. They don't have to go from least to greatest or anything, so long as the X value correlates to the same Y value that's shown in the chart. Then we have 83, 86, 74, 88, 76, 63, 90, 60, 60, 89, and 81. Okay, perfect. Again, I can't see them. I'm going to hit this. My graph is all over the place. I've got 1,000 up in the Y's and 10 down below. So I'm just going to hit the home button and try to find my little points here. Okay, there we go. Again, if we wanted to change our view, we can hit the toolbar. And instead of on my X, I'm just going to go 0 to 10 because the hours slept were from 4 to 9 hours. So I'm just going to do 0 to 10 and then we'll exit out. Oh, there we go. That'll tweak it a little bit. Much better. Kind of matches what I see from what I graphed. Okay, so then we have our linear regression equation, y1 squiggle mx1 plus b, and then my m, my slope, and my b value. So then I'll write that down. Linear regression equation, y equals m, which is 6.378, x plus b, 35.632. And I just chose to round off to the nearest thousandth, even though the directions never actually told me where to round. 3 decimal places seems like a pretty good spot. Okay, so from there, I'm going to find My y-intercept. Let's see if I can draw my y-intercept. No, I cannot graph my y-intercept because the smallest value on my graph is 60. So that's not going to work. So this time I'm going to have to find two values to use in order to make those 2 points to connect my arrows, or to connect the points to make my line of best fit. So I'm going to choose just 2 points, just any 2 random points. So I'm going to choose 4, and I'll plug in 4 for x and solve. So then there's my coordinate, 4, comma 61, and I graphed that. You can see here I had it already there in purple. And then I'll choose the number 8, plugged it into my calculator, got 86.656. And then I took the coordinate 8, comma 86, and I graphed it right here, again in purple. So then I was able to connect the 2 purple dots to create my line of best fit. And that is all that's required of this problem. Let me just quick reread the problem. So we just need to plot the data on a scatter plot. Perfect. Okay, so we are done with this one. Go ahead and try the second one on your own. So this temperature and water consumption. And then we'll jump down to the second part. Identify the data sets as having a positive, negative, or no correlation. So as one goes up, the other one goes up, or as one goes down, the other goes up, or maybe they have nothing in common. So best way to do this is just to go through a couple of them and see if it makes sense to you. So for the number 8, the number of hours a person has driven and the number of miles driven. So for however long they've driven for, what happens to the number of total miles that have been driven? Well, the longer you've driven, typically the farther you'll go. So this one has a positive correlation. More time means that you've gone further. The number of siblings a student has and the grade they have in math. I would say, yes, you always have those one-off cases where, well, maybe your older siblings are tutoring you and so your grade is higher, or maybe you have a bunch of little siblings and you can never focus on your math homework. We're not going to go into all of those like what if one-offs. Just in general, the number of siblings a student has and in general the grade that they'll have usually has no correlation. I've had students with many siblings do poorly, many siblings do well, no siblings do poorly, no siblings do well. I would say there's really no correlation to that. I'm going to skip the next 2. Those are for you to do. And then we'll do the number of years a person went to school and their income. So the more education you have, typically the more money that you will make. If you dropped out in 2nd grade, you probably won't find many high-paying jobs. If you went to high school, college, grad school, and have your doctorate, and now you're a surgeon, you're usually making some pretty good money there. So typically, the more education you have, the more money you have. And we're not going into just the one-off cases. We're just saying in general. And then the next one, the number of songs downloaded on your iPod. So before iPhones, you had iPods and it stored all of your music, and the amount of memory available. And then the iPods had a certain amount of memory on them. So this worksheet's pretty old. The more songs you have, the less space you have. So this is a negative correlation. Just like on your phone, maybe if your phone doesn't have a ton of room and you were thinking about like pictures and videos, the more pictures and videos you have on your phone, the less space or memory that's available left on your phone. So go ahead, go back and do the graph that we did not get to, or the graph that not that we don't have an unlimited amount of time, but the graph that I did not go over with you with, that was really hard to say. Number 10, number 11, number 14, and number 15.